Okay, in this video, I'm going to demonstrate how to find the solution for an absolute value inequality. We're going to be solving absolute value of 3 plus x is less than 5, but we're going to solve it graphically so I can give you a visual for why the solution falls within a particular interval. Some people are better visually, so we're going to go at it that way this time. In your graphing calculator, the way you would handle this is you would take the left side of the inequality and enter it as your first function. So you're going to have your graphing calculator graph the absolute value of 3 plus x, which is a V shape. And then as your second function, you're going to enter what's on the right side of the inequality, which is just y is equal to 5, which is a horizontal line. Now we're looking for where this shape is below this shape. That's what less than means. So we're going to specifically be looking for the portion of the absolute value graph that is below the line called y is equal to 5. And I'm going to demonstrate on the calculator how to get that entered. Okay, so in your graphing calculator, first, we're going to enter absolute value of 3 plus x, and I'm on a TI-83 plus. So where you're going to find the absolute value symbol is under the math key that is in this first column, 3 keys down. So right here, 3 keys down, math column. It is a number operation, the absolute value. So arrow over to numbers, and you'll see that the very first choice is absolute value. This particular calculator doesn't use absolute value bars, it just uses ABS. So press enter to select that choice. Enter what is inside the absolute value bars in your problem, which is 3 plus x. And then close the parentheses. Jump down to the second function. We said that we're going to enter y is equal to 5 for that one. And then press enter for that as well. You can make sure that you're pressing a standard window. If you, on this zoom key right here is where all the pre-made windows are. I'm going to use a standard window. There's my absolute value graph. There is my line called y is equal to 5. So we are specifically looking for all the x values that belong to this portion of the absolute value graph, because only this portion is below that line called y equal to 5. And again, since we're solving a less than problem, that means the portion of this graph that is below the other graph. So that's why I'm zeroing in on that portion. However, in order to talk about all these x values that belong to the portion underneath the line y equal to 5, you need to know where does it begin being below the line y equal to 5, and then when does it stop being below? So from here to here, it's below. Therefore, we need to know that intersection point between the two graphs right there, and we also need to know this intersection point. So the next skill we're going to discuss here is how to find those points of intersection. On this calculator, you would just go to Second, Calculate, which is that trace button. We're going to look for a point of intersection. You can arrow down or just select 5. You can just type in 5. Okay, your calculator will begin asking questions. When it says, am I on the first curve? It just means, am I on one of the curves? In order to tell your calculator yes, you just simply press the enter button down at the bottom of the calculator. So I'm going to get a little closer. Use these sideways arrows only so that you're staying on the actual graph. So I'm going to press yes, I am on one of the functions. Then you'll see that automatically the blinker jumps to the other function. Now it has jumped to the line y is equal to 5. So when your calculator is saying, am I on the second curve, question mark, that just means, am I on the other curve? Now it calls everything a curve, whether it's a straight line or not. So press enter again to say yes. Then it'll say, would you like me to guess at the point of intersection? Yes. Press enter again. And it now tells you that The absolute value graph intersects with the line y is equal to 5 at x equal to 2, which you can, if you visually drop down to the x-axis, you can see it's 2. All right, so we're going to list 2 as one of our points of intersection. Now we need to find this other point of intersection. So we're going to wipe all this work clean by doing another point of intersection. So again, start over, second, calculate. We're finding a point of intersection. Now we need to get that blinker over here. So again, use only the sideways arrows. We want to go that way. You can keep that key constantly depressed until it gets over. It'll move faster that way. Okay, so we're getting close to where we want to be now. Again, you're being asked the same 3 questions. Am I on one of the curves? That's what first curve question mark means. Press enter. It's automatically jumped to the other curve, the blinker. So am I on a second curve? Yes, you're on the other curve. Would you like me to guess? Yes. And so now we find out that the absolute value and this line y equal 5, they intersect at -8. You're not concerned with these y values because you're not being asked a kind of question that requires that y value. We're solving an inequality that has nothing but x's in it. So we're only concerned with the x values that the calculator is giving us by graphing means. So basically what you're now going to give as your final answer, we already have everything we need to give the final interval of solutions. You want to say that starting at this x value, -8, and then every x value belonging to this absolute value all the way up until you get to 2, all those x values belong to a portion of the absolute value graph that is below the line y equal to 5. So along this interval, all the x's between -8 and 2 satisfy this inequality. Now when you go to maybe back yourself up by solving this algebraically, maybe you want to prove that what you saw in the graphing calculator you actually did see. You can go to what you learned throughout the section about solving a less than problem. And that particular procedure for less than, that is, once there's no multipliers out here, because those multipliers, when you get rid of them, can sometimes change this so that it's not a less than problem at all. But we can be safe that this is the less than case because there's no multiplier, there's no numbers being added or subtracted out here. We're just ready to go into the less than procedure for solving it algebraically. So far, I've solved it graphically. And now I'm going to back up that answer, verify the answer by solving it algebraically. For less than, the procedure is take out the expression inside the absolute value bars and create a between statement. It'll be between the negative version of this number and the positive version. Solve it from the middle. This is a 3-part inequality, so you make your decisions at the middle. Whatever you do in the middle, you do on the right as well as the left end. This will be gone, leaving you with x, and you are between -x and 2. So you can see you're getting the same values as you did up here. Everything from, this is read out loud, between everything between -8 and 2. And we saw that graphically. That's exactly what we found as well.